Okay, you have to recognize on this one what this limit means, right? You just have to interpret that limit. Well, what is that? That looks like the limit of a difference quotient, right? So it's a derivative. It's the derivative, but what does the 3 mean there? At 3, yeah, when x equals 3, right? The 3 is what has been substituted for the x. So we're evaluating this derivative at 3. So this is really just equal to f prime of 3. Well, and at 3, we're just on that line. Just look at the slope of the line, and that's it, right? Slope is negative. It rises by -4, runs by 6, so -2/3. Okay? All right. Get with your groups. Remember your groups? Go with your groups because here's the next one. And go. We do this. So first of all, we're just going to check these things out one at a time, right? Does the limit exist as x approaches 5? Thumbs up or down? It does, right? Because the only place as we approach 5, we're on the, from either direction, we're on the top row of that piecewise function. The bottom row is the value that's assigned at 5, but the limit doesn't care what happens at 5. It only cares about what happens as you approach 5, right? So for part 1, if we take the limit of f of x as x approaches 5 is equal to the limit of x squared minus 25 over x minus 5 as x approaches 5. That's indeterminate, right? But how do I resolve that? Okay, I mean factor, right? Factor at the top. That's just a difference of squares. So we get the limit of x minus 5 times x plus 5 over x minus 5 as x approaches 5. We cancel the offending factors, right, that are causing the indeterminacy. We let x go to 5, and then we just get 10 as a result. Okay, so the limit does exist, yes. Is the function continuous? No, because the limit approaches 10, but the value of the function is 5, right? So that means that this point has been displaced from the function. Okay, give me thumbs on that. Does that all make sense? Okay. Is the function differentiable? Do we even have to try? No, how come? Because it's not continuous. Differentiability implies continuity. In other words, differentiability requires continuity. So it's only one. Okay? Good. All right. Come up and get your just desserts, everybody. Okay, so yeah, how does this work? Well, we're looking for the slope of the red graph gives us the value of the purple velocity graph, right? So what do we notice here? If we draw tangent lines, and that's really a good idea here, is to draw little tangents. Well, look at this tangent right here. That's zero slope, right? It's getting steeper. It's getting steeper. It's maximum value right there. So there's that part of the velocity graph then, right? Starts with a value of 0, increases to some positive amount, and it actually looks like that amount is 1. It is 1. You can see if I look at the slope of this line, I rise by 5 and run by 5, right? Little squares, okay? Rise by 1 and run by 1, okay? Really what that means. And then once we get to here, it just stays at a constant velocity, which is what is shown there, okay? So there's the velocity graph. Now the acceleration graph. To be totally correct, you really need to have open endpoints there. How come? How come, Max? Because it's undefined, right? Because you have a sharp corner and derivatives are undefined at sharp corners. And so I need to omit that value from the domain of the acceleration function. Acceleration is undefined at 5, okay? And you see why, because think about what we're saying would happen there. We're saying you would instantaneously change your velocity from 1 to 0. Well, for any object with mass, that would require an infinite amount of energy to accomplish, which isn't available, right? Because if you not many people are in physics here, but that would mean you're changing your momentum instantly, which you can't do. Rate of change of momentum is force, and that would require infinite force. Okay, but we don't need to get too far into that. You just need to see that based on the shape of the graph, it's undefined because it's a sharp corner. Okay, give me thumbs on that, on the explanation. Is that making sense? What we did? Okay, and this stuff just takes practice. You get some practice on the homework on this too. Oh, acceleration. Okay, I guess I didn't talk about how we did that. Acceleration is the derivative of velocity, right? And so this first section of the velocity graph has a constant positive slope, right? So the acceleration is positive and constant, and then it shifts to a constant zero slope. So the acceleration drops to a value of 0. Okay, does that help? I forgot to say that part. Okay. All right. So come up and get your. All right. So why? Why would it have at least 2 zeros? Well, here's why. Look, if we know that the function is differentiable on the open interval from -2 to 8, if it's differentiable, what does that say about its continuity? It's continuous, right? Differentiability implies continuity. And if a function is continuous on an interval, on a closed interval, right? What does the intermediate value theorem tell us here? If we know that if f of 0 is 3 and f of 2 is -3, and it's continuous on the interval from 0 to 2, which it is, right? Because that's a subinterval of this larger interval where we already know it's continuous. Then the intermediate value theorem says that it has to pass through every intermediate value, including 0, at least once somewhere, right? So we know it has to have at least 1 0 between x equals 0 and x equals 2. Agreed? By IVT. Okay. Also, if we know that f of 2 is -3 and f of 7 is +3, then it must also pass through 0 between x equals 2 and x equals 7. So you get a total of at least 2 zeros, at least, could be more, but we have at least 2 by IVT. Okay. And then, well, 2 is given, right? If it's continuous on the open interval from -2 to 8, then that means the closed interval from -1 to 7 is a subinterval of that larger interval. So that has to be true, okay? And then how about this last one? For some c between 0 and 7, f of c equals -2. Well, let's see, between 0 and 7. So if you just look at between 0 and 7, it says 3 and 3. So that doesn't guarantee anything, right? However, we know that at 2, the value of the function is -3. So we know that between 2 and 7, the function has to pass through the intermediate value of -2. So therefore, if it happens between 2 and 7, it necessarily has to happen between 0 and 7, right? Okay, give me thumbs. Does that make sense? Okay, all right.